Yes, now don't spam the chat. Very good. Yes, we are recording the session. It will be uploaded and the videos will be available. Don't worry. Okay. Okay. I'm officially starting the class, guys. Finally. Quick yes, quick like just react. Now you don't even have to type. Just react. We'll quickly begin. Finally. Okay. Yes, everyone is muted, so you won't be able to speak until I unmute you all. So we'll do that at 11. We'll talk only after 11. Never thought I will love Teams. Nice. Okay. So let's do a quick recap and then follow up on what we learned last week. For those for whom it is first class, don't worry, we'll still be able to follow. So don't get overwhelmed by the terms monolith microservices. It's fine. You will still be able to follow. Okay. So we took the example of Zerodha last week. Let's continue on that example, or let's probably talk about, say, Amazon. So basically, we are the client, basically the user of the system. And what we are going to do is now try to build a system. So last time we talked that we can either have one server, basically one huge code base, which we can call as monolith, or we can have multiple servers, multiple small servers. Now, for example, that this one server takes care of order management, one suppose takes care of reports, one suppose takes care of, say, auth, and so on and so forth, right? So what do we call this? I'm going to the chat. So what do we call having multiple services, dividing our huge code base to smaller code bases and having multiple services? Microservices, correct. Now, so basically, now let's try to imagine that what happens now. Okay, we also have to store our data. So what is going to be there for storing our data? There's going to be some databases. Yes, so there's going to be DB. So everyone understands this much that we have multiple servers, we have databases. Yes, we are going to store our data. Now let's talk about that. Okay, if we also talked about that there is going to be a load balancer. Now, why do we need a load balancer? Now, when client sends a request, maybe client is sending a request for auth, maybe client is sending the request for reports, maybe the client is sending the request for order management, correct? So there's a load balancer over here who's making sure that the request is that request goes to the correct server. Everyone understands this much. This much is like basics. Client sends request to load balancer. There are multiple servers called microservices, and there is some data in the database. Everyone understands this, right? Now, what's going to happen is let's imagine that one of this servers goes down. Now, order management goes down or reports goes down. What happens now when load balancer asks for reports? We will not be able to serve the request. Do we want to design such a system? No. Don't want any what? We don't want any single point of failure, right? We want our system to always be able to respond, right? So that's why we okay, just think about it. Suppose you don't know anything about system design. I tell you that one of the servers is crashing or can crash at any point and you don't want a single point of failure. What would you do? What you could probably do is probably have more servers just for order management, more servers just for auth, more servers just for reports, correct? So now there can be multiple servers for say same microservice added. Okay. Now let's think about it. How can we do this? Now there are different ways to implement this also. One way is that okay, request suppose now there are three servers for order management. There is server one, there's server two, there's server three. One way is that all my requests are all my read, write requests, all the requests are being served by this one server. And what am I going to do is I'm going to copy or replicate the data to server 2 and server 3. Okay. What am I doing? I'm doing replication. And now what happens is that if this server goes down, one of the two servers can take over, right? That is one way to go about it. Everyone understood this much? What did I say? I said that this server might go down. So what I did copy of this server. So basically same code that was there in this server, in server one, I added it. I added two more servers with the same code. server 2 and server 3. Now what I did that when this goes down, I'm going to get 2 or 3 up. So 2 or 3 are of no use until one goes down. So what I'm doing is I'm just keeping a copy of the server, right? And basically this is called what? Can someone guess? Basically, this is the leader. These are the replicas. What is it called? Shadowing, yes. Or leader election, master slave, yes. Or so we will talk about leader election and terms like these in databases when we discuss them last week, next week. So basically, master slave means what? This is the one who's going to be responding to all the requests, but when this goes down, one of these two will take over. That is one way to go about it. Another way to go about it is that
नहीं.
I would kept three servers. One, okay. Somehow I went on mute. Can you all hear me? Was someone was able to mute me. I don't know. I checked the settings, but guys, don't mute me. Okay. Okay. First day. Don't mute me, guys. Okay, cool. So we'll just quickly repeat it. So what did we discuss till now? See, so requests are coming to the server. Firstly, I said that server can go down. So there are multiple ways to deal with it. Okay, one way is that I have two backup servers or basically slave servers if this is the master server. So if this goes down, these two servers are going to take its place. Or one way is that I have three servers. Some requests go to server 1, some requests go to server 2, some requests go to server 3. Now there are different ways in which I can decide, okay, which request should go to server 1, 2, 3. This is load balancing and we'll discuss in detail day after tomorrow. So day after tomorrow is for load balancing caching. We'll discuss this. Okay. Right now we are discussing the entire system, how the distributed system looks like. So you will hear the term distributed system a lot, right? So what we are going to do today is we are going to get used to all the jargons very properly. So you will understand that, okay, what this means. As soon, so basically, you will be ready to act like architects. So you will be used to all the jargons by the end of this class. Okay, so we understood that we don't want a single point of failure and we are deciding distributed systems. So there is one way that we talk master slave architecture, one way that we discuss that, okay, we can balance the load between multiple microservices, right? Similarly, for database also same thing. So we can have suppose one database which has some user information or some information. So we can have replicas of the data. So if there is some user info, probably I have one database. Now, what if this database goes down, if this database is not available? What is going to happen? We can either replicate it or what we can do. So basically, we are replicating all the read and the write requests will go to this database only, and we are replicating it. So if this goes down, this will come up. Or another way to go about it is that we could have divided the data that, okay, from user 1 to 100, data will go to this database. 101 to 200 will go to this database. 201 to 300 will go to this database. So we could have either divided the data to multiple databases. Yes, sharding is the term. We will do this next week when we discuss databases in detail. Right now, you understand the point that there are multiple ways to handle that we do not want our data to be lost. We want our system to be available, correct? So basically, we are designing distributed system. What does even distributed system mean? So basically, there are interconnected computers that work together over a network is the actual official definition. What does it mean? I was muted. Guys, stop muting me, please. This is getting annoying. Okay, please don't mute me. I'll have to find you and I'll have to kick you out. So please don't do it. Okay, cool. There are a lot of people. Let's try to not waste each other's time. I'm already feeling bad that we wasted a lot of time. Let's get started. So I don't want to spend time checking the settings and all that. Just be nice, be mindful of each other's time right now. Okay. So what are we trying to do? We are trying to design distributed systems. What is a distributed systems? It is a network of interconnected computers. So basically computers are connected over network. Very easy to say computers are connected over network, but there are a bunch of issues that come with it. So we'll discuss all of that today. Also, see, there's a very the misunderstanding that distributed systems means we are talking only about the backend. There's also something called distributed databases, right? Like Cassandra, MongoDB. We will discuss this in detail next week. So these are what? These are distributed databases, right? Similarly, there's distributed file system. Can someone give me an example of distributed file system? Can anyone think of distributed file systems? Hadoop, yes. Hadoop Spark, yes. Very good. HDFS Google, yes. Very good. GFS is also there. So there are many distributed systems. Basically, what means the components are connected over network. That is what, in simple language, that is what it means. But it comes with a lot of problems. We'll understand. For now, what we have understood that, okay, there's a client, there's a load balance, there are multiple services, and now we want to avoid single point of failure. So either we can have backup or we can have something like master slave architecture. Similarly for databases also, right? Now let's think that if we have multiple databases, now what I'm going to say right now is not true just for databases, but it is easy to explain for databases. So I'm taking the example of databases, but you need to keep it in mind that it is true for all the systems, not just for databases, and we'll discuss it in detail. What happens that everyone uses databases to explain it because it is very easy, and then people get overwhelmed that okay, only databases or the entire system, and we'll discuss this point as well. Okay, now what we did, so I said that I decide that okay, I am the client, there are some server over here, something request is going, there's a load balancer, right? Now this is my master DB, or basically my main DB, or you can say the leader DB. Okay. So what this DB is doing is it is taking care of all the read and the write operations. These two DBs are doing nothing. They are just the replicas. Replicas meaning what? They are just the copies. Okay. You could actually do read from there or do read or write both. So let's just take the example that for now, this DB is taking care of read and write, and this DB is taking care of, if this DB is doing nothing, it is just taking care of replicas. So this is one way to go about it. So now what happened that all the servers are talking to this particular DB. Now this DB is getting overwhelmed. Now we saw our system requirements and we saw that, the number of read requests that come is far more than the number of write requests that come. So we decide that because these two have the same data, why can't one of these be used for reading? So now what I do, I allow these servers, these databases for reading. So basically, if there's a write request, it is going to go only to this database. If it is a read request, it is going to go to both the databases. Let's just try to think of it like this. Okay. Now what happens is, suppose a write request came. Okay. I wrote the data, suppose some data to suppose value 1. Okay. I copied it over here. I copied it over here. So value in all the three databases is say 1. So what is this one? Suppose it is user ID. So user ID 1, user ID 1, user ID 1. Now another request came and I said that, what, update the user ID. User ID is not 1, it is 2. Some request is coming. Okay. Now what happens, because these two are going is like, these two can be used for reading. While the write was happening or right after the write happened, a read request came to this particular database. Now, see, the data in this database says that the value is 2, but the data in this database says the value is 1 in both of these databases. Because we were not able to copy the data or we were not able to replicate the data before a read request came. Right? Yes. So as people are saying, it is not consistent. So this is what consistency means. Okay. So consistency means that as soon as we write something, after that, if any read happens, right, then we should be able to see the latest data that we synced. Otherwise, it is not consistent. Okay. Now, someone used the term eventual consistent. What does eventual consistent means? So suppose if there was a gap of say 1 minute in between that write request and the read request, What could have happened is then these databases would have synced among themselves. Then this database would have told these two databases that, yeah, update the data to 2, right? In that case, the value would have been correct. So there is a bit of lag in the consistency. So what is this called? This is called eventual consistency. So it is not like it will be always there, but eventually after some time we will sync and we will make sure that it is consistent. Okay, everyone understands this. So basically all the nodes or replicas in the system should have the same data at any given time is what consistency says. Now I said that there are levels of consistency. If there is one eventual consistency, what are the other levels of consistency? One is strong consistency. Strong consistency means that at any point, even if the write just happened, I don't care. I always want the same data. There can be cases like this, right? And let's try to think of cases. Today we'll take a lot of examples. So one very, very common example that everyone give for strong consistency, and it is a system that is asked in interviews also, right? Banking or ATM. So basically any systems which are very crucial for transactions. So suppose ATM machine. So very simple example, let's take, I had 20 rupees in the bank. I went and I withdrew the 20 rupees. So this is 0. Okay. So there's another ATM machine. There was 20 rupees. My mom came. She said, okay, Kirti has 20 rupees. I need 20 rupees. She also took 20 rupees. Cool. Now, since both of them took 20 rupees, these two machines did not get time to sync together. And now afterwards, what happened? That the value became minus 20. That is a huge problem. So I want my system to be strongly consistent. That means that I should not allow any withdrawal without making sure that, okay, all the other ATM machines are like, not working right now. Basically, there's some locking mechanism, or basically we're making sure that, okay, all the systems, have the same data. How do we do that in a distributed system? Okay. Now my question to you is that how can we have strong consistency in a distributed system? This is my question. Let me repeat that. So my question is, suppose there are 3 databases. Okay. So right now, let's say all 3 are like we can read all 3, we can write all 3. I want strong consistent system. How can I have strong consistent system? Synchronous replication. Very good. Now, what does synchronous replication mean? It means that if I send a write request to this database, say this database's name is 1, I send a write request over here. Before accept, like without even before even saying that, okay, I have written it properly, before even acknowledging this, right, what am I going to do? I'm going to sync it. Without like this request, without making sure that the databases are synced, I am not going to respond saying that write is successful. And if the sync fails for some reason, maybe I will just respond failure and I will roll back to the original value. You understand? If I want the strong consistent, what is happening? Let me repeat that. So there are 3 databases, database 1, 2, and 3, right? Give me 1 second, guys. Just turn on better video also for a backup. Yes. So basically there are 3 databases right now, and all 3 are sorry. Yeah. So there are 3 databases. All 3 are taking read and write requests. A write request came to this particular database and it said that, okay, write some data to say value 2 or value 3, whatever, some write request came. Now, before even acknowledging that, okay, the write request is completed, what this database will do is it will tell the databases 2 and 3 that go update that, this is the updated value, update it right now before I finish my write operation. So if this synchronization is not possible, there are multiple ways to handle it. Probably it can say that, okay, failure has happened, write is not successful, and the others will also roll back to the last value. So this is to make sure that the system is strongly consistent, strong consistency. Yes. What would have been eventual consistency? That there are 3 databases. Someone said right and I responded. And then after responding, what am I doing? I am updating these 2 databases. Now, after responding, I'm doing what problem could have happened? That an immediate read request would have come and I would have written the old data instead of the new data. So maybe after 1 second or after a few milliseconds, the data would not be correct. But with time, eventually, say after some time, eventually it will be consistent because the synchronization will happen. It will happen, but there might be some delay. So that is why this is called eventual consistent. Has everyone understood strong consistence and eventual consistent? How do they synchronize, and all of this we'll discuss in database. But for now, can you understand what consistency means, what strong consistency means, what eventually consistency means? Let me tell you some one interesting point. So there's something also called read your write consistency. So this is just another thing that is there. So what this says is that if a particular client is writing something, then that particular client should always see strong consistent data. What does it even mean? So it means, see, suppose I am writing some social media post. As soon as I put something on Instagram, I try to refresh it to see that, okay, was I able to post or not? It is okay if everyone else is able to see the post after, say, 2 3 minutes or after 5 minutes, but since I was the one who posted, I should be able to immediately see it. Correct? Yes. So that is called read your write consistency. So there are consistency levels that we can say, right? For now, the important thing that you need to understand for system design is strong consistency and eventual consistency. Is this clear? Can I move ahead? Everyone understands what consistency means. What is not clear, Angad? I need you to tell me. Why can't we make other DBs to wait until update is done? See, it is just making it slow, right? If we see, this is what we were doing over here. This is what we were doing over here essentially, right? We were making the other DBs like update before responding. But then our system is going to become slow. We also want a system to be very fast. Yes. So someone is asking me to repeat RYW. So basically that's read your write consistency. So it says that the user that performed the write, at least that user should always see the latest data. It is okay if other users see eventually, but that user should always see. So there are different ways to do it. So basically we'll make sure that that user's request will go to the same database, or we will cache it, or there are ways to figure it out. But it is something, just some interesting point that I wanted to tell you, that basically if I am putting a social media post, just think about these cases, right? So if I put it up on Instagram, it is fine that if you see my post after 5 minutes, or if after 2 minutes, 3 minutes, it's fine. But if I have posted it, I should be able to see it everywhere. Otherwise, I'll go like, oh, I just uploaded it. Why am I not able to see it? And I might post it again, right? So isn't it important that at least I am able to see my post immediately? So that's called read your write consistency. There are different levels of consistency. The usual ones that we discuss is strong consistency and eventual consistency. Okay. What will happen if a database which is serving write request goes down? Yes. So that is why we discussed that there are multiple ways. So basically what happens is we can have one handling write and we can have two backup servers and the backup databases, and one of them can take over. Okay. We will discuss the detailing. Right now, I want to move ahead. Okay, so we discussed that we can have strong consistency. How? By having synchronous replication. So also want you to get used to all the words. Synchronous replication. So one way to make sure that strong consistency is served. Okay. Now we said that we want our databases to be strongly consistent, and it makes sense, right? That whatever we read should always be true to what we wrote. Correct? Now there's another quality of the system that we are designing that we want to have. Okay, by the way, consistency is what? It is a quality of the system. Yes, that our system should behave like this. And that is why it will come under what sort of requirements. So I'm going to begin try and tell you that, okay, what all things you have to do in interview also. So in every system design interview, in the beginning, you will ask something called functional requirements, and we will talk something about non-functional requirements. Okay, can someone quickly tell me in the chat that what are functional requirements and what are non-functional requirements? Say for a system like YouTube. For a system like YouTube, basically uploading the videos, watching the videos, these are the functions that YouTube performs. But making sure that we are able to see the videos very fast, making sure that it doesn't that the YouTube always works, it never goes down. Those are called what? Those are called non-functional requirements. So in every interview, in every system design interview, this is where we start functional requirements and non-functional requirements. Today, we are discussing non-functional requirements in detail. One of the things that we discussed was consistency. And once we understand all the non-functional requirements that a system can probably have, we will today itself, we will take a lot of examples of systems. We'll take YouTube, Amazon, Uber, Ola, anything. Basically, we will take a lot of systems and we will try to come up with the non-functional requirements for every system, right? It is very easy to understand, right? So basically, functional means functions that the system is performing. Like what? Like Uber's system does what? It makes sure that we are able to ride, we are able to book the ride, right? Swiggy, Zomato does what? We are able to order. Or Amazon, we are able to order. We are able to view the reports, or we are able to see our transactions. All of that are functional requirements. What are non-functional requirements? That our system is very fast, or we will discuss the technical terms. Latency is less. Consistency is one of the non-functional requirements. What does consistency mean? That our data, whatever we have written, whenever we read the data, we are able to see the latest data. So consistency is one of the non-functional requirements. Similarly, the next non-functional requirement, can anyone guess that, what is the other very important non-functional requirement that we might want to discuss now? See, as we had discussed in the starting, yes, very good availability. See, we don't want our systems to go down at any point in time. Like any system we are designing, suppose we are designing YouTube, we don't want YouTube to go down. WhatsApp, we don't want our WhatsApp to go down ever. We should always be able to see some response, right? We are making distributed systems. And what do we want? We want our systems to be available. So availability is the next thing that we are going to design. Okay. Now, why is availability such a big issue? Just imagine you opening any system and there is like no response. It is okay that, if the response is wrong, it is fine. You can refresh it and you can wait for it. But the experience is very bad when the system is not available, correct? Or when the system is down. So basically, the ability of the system or service to remain operational or accessible. So operational or accessible is the key term. Okay. And how is it measured? Can anyone tell me that how? Mohit is saying that like today Swiggy was down. Correct. Right. Can someone tell me that how do we measure the availability of the system? Very good. So a lot of people already know this. So availability of the system is mentioned in SLA and it is mentioned in terms of nines. Okay. Can someone tell me what does SLA stand for? It is service level agreement. So you don't need to know this for interview perspective about SLA, but just good to know information. So basically, any system when like you're using a third party app, a third party say cloud service or a third party vendor, they specify the level of service performance that the provider is guaranteeing. That okay, this is the performance that you will always have. So when we talk about uptime, downtime, what do we say? That out of these many hours, like out say in a year, what is the worst case that you can imagine? That how many hours can WhatsApp or YouTube go down in 1 year? Can you tell me how many hours do you think it is okay that YouTube goes down? Is it okay that YouTube goes down, say, for a total of 24 hours in 365 days? Is that a good thing? Like 24 hours. So randomly, like for 24 times, you might open YouTube and it might not be working. You might be depending on a YouTube video, like you will watch it right before your exam and then it stops working. Will you have trust on YouTube or WhatsApp or anything after that? Maybe you wanted to send your notes on WhatsApp and it stopped working right before your exam. And now you have no idea. Okay, now you have not received the notes. What are you going to do? So you have to have that trust on any system, correct? So as a lot of you have already said, so there's something called nines notation. What does it mean? We are going to discuss now. So it tells that for how long your system is always going to be available. Okay. As the nines increases, the system becomes more available or more reliable. Let's talk about it. So when we say two nines, that means that your system is 99% available. 99% available means one can someone calculate that if there are 365 days, every day has 24 hours, 99% available means what? It is going to be down for how many hours? Can you quickly calculate? It is going to be down for 87.6 hours. Do you think it is a good system that out of 1 year it is going to be down for 87.6 hours? Probably it is definitely not good for critical systems, probably acceptable for non-critical systems. Like suppose you're watching my tutorials, it is fine that it goes down for say 5 minutes in a day. But if it starts going down, suppose 1 hour a day, it is not acceptable. So two nines means that your system is going to be up for 99% of the time. Three nines means what? Can you guess? Obviously, you should be able to understand. Like you should be able to guess by now. 99.9% of the time. 99%, 99.9% uptime means what? That it is going to be down for 8.76 hours per year annually. In 1 year, it is going to be down for this much time. Now, this usually is acceptable for many businesses, right? That in 1 year, 8.76 hours, okay, fine. We will live with it. But usually for critical systems, like we had discussed, banking or any other critical systems, can you think of any other financial systems, communication networks, online services, any of these systems? We want what? We want four nines. Four nines means what? 99.99 percentage, right? 99.999 percentage means what? It is going to be 52.6 minutes in entire year per year. So in 1 year, 52.6 minutes seems to be very, very good, correct? Uh, Now tell me, do we even really need five nines? Is it possible? Do we need five nines? Because we already talked about banking, communication systems, all of this four nines, correct? So what do we come to now? So five nines, do we need it? So five nines means what? 99.999%. There are five nines. Okay. Five nines basically comes under high availability, that our system is going to be available. So we discussed about levels in consistency, right? Strong, consistent, eventual, consistent. Similarly, over here in availability, there are levels of the availability. Two nines, 99%. Three nines, 99.9%. Four nines, 99.99%. Five nines, can you guess any good example of five nines? Imagine any mission critical systems, like suppose healthcare systems, right? Where your health, your life is dependent on it, like healthcare systems. Or suppose uh, you know you are going on mission, something, some airlines, yes, you can say probably very, very critical systems, correct? So five nines. See, six nines is actually extremely challenging and it is usually not possible in software world, but just letting you know, obviously there's six nines also. Okay, it is possible, but then you would have to put in like millions of rupees into it. Suppose it could be suggested for say space missions. It will be obviously very, very costly. You would not want it. So basically only in systems where some sort of disruption will happen if you don't support it, then only you would spend so much money on it, right? So what sort of availability your system provides, you're going to write in what? You're going to write in service level agreement. You mentioned that this is how my system is going to perform, right? Okay, has everyone understood consistency and availability? Do you need a quick revision or can I move ahead and then we can probably come back to this? What is the difference between microservices and distributed systems? See, distributed systems means computers over network. Any system. Now, distributed databases, distributed file system, or distributed backend, like it can be any distributed system, right? But then when we talk about um, this, sorry, I got a message here. So basically, microservices is basically on backend, correct? So there is no We are not talking about a system, we are talking about servers. So either the service is like the entire code base is on one system or on multiple servers. So that is microservice. Yep. Revision on consistency we'll do later. Yep. Okay. So people are asking for strong consistency, eventual consistency. We'll quickly cover it and then we'll move ahead. So consistency means that as soon as you write something to your system, when you read it, you should be able to see correct data. Very simple. Okay. Strongly consistent, basically banking, ATM. Whenever you make any transaction, immediately you should be able to see the same data only. It should not be like that, okay, because there's a difference of some milliseconds, it is fine. It will be eventually consistent. You can't do that when it comes to banking or financial systems, right? Or very like systems where these transactions are very important. So that in that case, you want strongly consistent systems. So what you're going to do in terms of database, just to explain you, we can do synchronous replication. What does that mean? That when I'm trying to write to this database, before even telling that, okay, write is successful, when the write request comes, I update in this database, then I'm going to update this database, I'm going to update this database. When the write was successful in all the replicas, only then I'm going to respond that, okay, write was successful. If it suppose if this one would have failed, probably I can do retry, or maybe I can roll back my data also and this database's data also, and only then I will say that, okay, it was not true, like there was a failure, we were not able to write. Okay. So we are making sure that we do the replication before we even respond. That's synchronous replication. Here we are doing asynchronous replication. Basically, we responded that, okay, yeah, I've written. So, but the data is updated only in this database. After I responded, I am going to update my data to these two databases as well. Yep. So now we have talked about strong consistency, about eventual consistency. We understood what are functional requirements, what are non-functional requirements. We understood SLAs, nines, that okay, what are two nines, three nines, four nines, five nines. Yep. So we understood that we want our systems to be very consistent. We understood that we want our systems to be highly available. But how can I increase the availability of my systems? Can you think of any solutions? How can I make my systems available? How can I increase the availability of the system? Okay, Naveen is saying replicas. That is one way. Yes, replicas is one way. So you can do replication. So basically, if one goes down, we are going to have another way. We are going to have backups. What? Anything else? Scaling, yes, scaling is one way. So basically, scaling means what? So there was one server, now I have three servers. So basically, even if one goes down, it is fine. These two are still taking the request. So horizontal scaling, we will discuss scaling in detail next week when we discuss database. But I hope you're able to understand that, okay, one server, multiple servers means we have scaled our system. So earlier request was going only to one server, now request is going to multiple servers. So replication is one way, scaling is one way. What other way to increase the availability? Can anyone tell me? CDN. So someone is saying CDN, but okay, to explain it in easy terms for those who don't know CDN. So basically, you can think about it like geographical distribution. So basically, what would happen? Let's take this example. So suppose my server right now was in Manali, and now Manali has huge floods problem right now, correct? So how would I deal with this? Like my service was in Manali, and now entire system is down. Even if there were say three servers in Manali, now the entire system is down. Or suppose somewhere earthquake came and they all my servers were over there. So natural disaster happened, right? All the systems are down. Now my system is not available. So I will make sure that the servers that I have are in different geographical locations. Says one is in Delhi, one is in Bombay, one is in Bangalore, suppose one is in Manali, wherever. We will make sure that our systems are in, we are, we have located it at different geographical locations. Okay. Any other thing that you can think of? Yes, yes. Okay. One more thing that I am seeing that no one has told. So someone has said reverse proxy, but okay, I'm not going to get into the detailed terms because there are a lot of beginners. So there's one way of load balancing. What does load balancing do? How does load balancing help in better availability? Can anyone tell me how does load balancing help in better availability? So basically what happens is sometimes availability might go for a toss because one server is taking care of entire of all the requests. So basically congestion is going to happen. By load balancing, what happens is that we are going to balance out a load. So now some requests are going over here, some requests are going over here. So this one server or this one database or whatever, this one component is not overwhelmed. So basically, we can also do load balancing. Yes. So how can we increase our availability? First of all, replication. Okay, this related to replication, there is another term that you will often hear, redundancy. Can someone tell me what is redundancy? So basically, you are repeating the data. So now redundancy could happen at any level. So when we say replication, it is not just in the matter of, say, databases. You could have redundant hardware components, network parts, power supplies, data storage, anything. Okay. So you could have, we will talk about this more in detail, but right now I hope you can understand it is not just about redundant data. It is also about hardware components, right? Or about network paths or power supplies. Correct? So basically anything that you are copying, you are storing again. Basically, you're storing redundant things. Okay. Load balancing. So now no one single server is overwhelmed. So now someone had actually said failover mechanisms can also be there. What does failover mechanism mean? So if something goes down in one server, we are going to make sure that the other server automatically picks up. Same for database also. Correct? Disaster recovery planning is one way, right? Monitoring is one way. So basically, we are monitoring. We will see that okay, our server is about to get overwhelmed, no, about to get overwhelmed, and we will discuss these points. So if in an interview someone asks you how can you improve the availability, you're supposed to think of all of these points. Firstly, you could replicate the data. You could have redundant data. You could scale it out. You could place it in geographical locations, load balancing, failover mechanism. But how do you even prevent it? How do you prevent it? Monitoring, right? Monitoring leads to scaling. Very good, Love. Also, probably you could use, so just saying it out. So basically, a lot of people, what they will do, they will just host one server. Instead of doing that, probably try to use cloud services because they are already distributed solutions. There are already solutions that are going to help you out with high availability, right? Or you could do, say, scheduled maintenance. So maintenance, basically, you are going to check that, okay, everything is running properly. You are probably going to have some testing, simulation. So a lot of companies, what they do, so they simulate the worst case situations. Like with the third party app that I have integrated for this course. So what they did, they simulated the number of students. They simulated the number of students to be, say, 1 lakh, and then they tried, were we able to take the load or not. Similarly, for YouTube or for say any system like that, when you are actually designing a system, you're going to simulate the worst case scenario, the maximum the maximum amount of requests that can come, and you will see that okay, is your system able to take it or not. And yes, and probably you could have some maintenance, security measures and all that. So basically you have got the point that we want high availability. So all of this, I'm going through the chat once to make sure I answer all the questions. I was getting one question. I just read it in between. I was talking between replication and something. Replication and scaling are the same as the doubt, I think. So we will discuss it when we do horizontal and vertical scaling in databases. So basically, replication means we are just copying the entire thing. Scaling necessarily might not be that. There's also something called vertical scaling. That means that we are just increasing that, how much load our one server can take. So suppose right now my system was say of 8 GB and I have expanded the same system to be of say 16 GB. This is also scaling. So this is called vertical scaling. Okay, so there's something called horizontal scaling, vertical scaling. Replication and scaling is not exactly same. We'll discuss it in detail. Okay. Load balancers we're discussing day after tomorrow. But is this much clear that in our systems, we want our systems to be very consistent. We want our systems to be available. Now, there are different levels of consistency. There is strong consistency, there is eventual consistency. When we come to availability, there is nines of availability and it is mentioned in SLAs. So availability can be say 2 nines, 3 nines, 4 nines, 5 nines, 6 nines like that. Yes. Yep. Has everyone understood this much? Failover mechanism, see, there's nothing. So basically, if something goes down, we should be able to, or there should be automatic that another server or another database can take over the failed component. We will discuss it in detail, but in very easy terms, that if one database fails, we should have a backup. Yes. Yes. Thank you, Teja, for answering that. Okay. Can we move ahead? So now we decided that any system that we are going to design, we are going to make sure it is very consistent as possible. We are going to make sure it is very available also. Okay. So we made sure that all of this happens. Now let's try to see that is it even possible to have strong, consistent and highly available systems. Let's try to design a system and let's try to see what all problems we will have because it's a distributed system. Okay. Let's take the example of say databases. So we have two databases right now. Okay. What do we do in this database? Okay. Rama, don't ask me questions that I have not covered till now. Then you know what you're doing is I understand that you're very excited, but it is just going to take my attention. You're going to just divert my attention. I'm covering everything. So relax. Okay. We'll cover everything. So, okay. Now there are two databases. Guys, ask relevant doubts because I'm reading the chat and I'm answering the questions. So make sure you ask relevant doubts. Everyone clear with availability, consistency? Can I move ahead? Just tarifying load balancers to balance the request to different servers containing same service, not to different services, right? Servers containing the same, not it can be. We will discuss the type of load balancers day after tomorrow. Okay, cool, awesome. Now we have two databases. I know I made this so many times, but okay, we have two databases. We are doing read and write in both. Now what we did that what we do is when we update some information over here, suppose we have say price of some stock. Right now, price of the stock is say 100 rupees. Over here also price of the stock is say 100 rupees. We update and we say that you know what, now the price of the stock is say 200. We have updated it over here. Now we can do multiple things that we had discussed that as soon as we write, what we could do is we could tell this database that you write this and then we will respond that, okay, write successful. That is one way to go about it. Another way that we discussed is that these databases are there and initial prices was 100. When we wrote now 200 came, now we said that, okay, successful. And after this, I'm going to tell this database that, you know what, you also update your value to 200. Okay, now two ways to go about it. Now, just imagine now because this communication is going to happen how? It is going to happen over network, correct? So when this happens over network, we could actually lead to a bunch of issues. Maybe there is a network failure. Maybe there was a congestion. Maybe there was some routing issue. Maybe some natural disaster happened. Something happened. And this communication is now not possible, right? Now we cannot communicate between these two databases. So now what has happened? There is a partition between components, right? So when there is a partition between components, what happens? Now this partition can again happen because of multiple reasons. One is say network failures, right? Another one is say network congestion that okay there were too many requests and the server got overwhelmed or something like that. Maybe there was some routing issue, right? Maybe some natural disaster happened, something happened. So now this has been partitioned. Now let's try to see can we still support both consistency and high availability. Let's try to support both. Okay, two databases, initial price is 100. Request comes. Now I want to update it to say 200. I updated my value to 200, right? I cannot communicate to the other database, right? Now, if a read request comes, the value is still 100. What is the problem? I wrote 200, but the value that I have returned is 100. So my system is not what? So my system is not what? It is inconsistent. It is not consistent. Very good. Guys, reply. Yes. Yes. So it is not consistent. It is inconsistent. How is it inconsistent? Because we updated the value to 200, but the value that we see is 100. So we were not able to synchronize. Very good, Rama. So we were not able to synchronize because of what? Because of a partition that happened in between. So in this case, what happened? Our system is inconsistent. Let's take another example. Database, partition. I say that because prices, I cannot afford that I return 100 price. So what am I going to do now is that since I have said that, okay, update the price to 200, and I know I cannot talk to this database, maybe what I will do is I will stop serving requests to either this database or to this database. I will make sure that one of the database stops responding to make sure that whoever reads is reading the same data. So if the value is updated to over here, suppose I will read from here only. I will not read from here. So now what has gone for toss? Now what has gone for toss? I make sure that whenever I'm reading consistent data. But now what am I doing is that now my availability has gone for toss. So it is not available. English, not available. Right? So in this case, our system was not consistent. In this case, our system was not available. Okay, I'm going to explain this again. Everyone think, like listen very, very carefully. There are two databases. I said that there's a partition. What do I mean by partition? They are unable to talk to each other. Okay, that is what I meant by partition. So initially, what did we discuss? That for the systems to be consistent, we have to synchronize the data, right? We have to let the other database or the other node know that, okay, this is the new information. Okay, that's how we discussed that our systems can be strongly consistent, correct? But now if this communication cannot happen, now this communication could be blocked because of multiple reasons. One reason is suppose network failure or suppose network congestion, routing issue. Or sometimes what happens, there can be security measures like firewall issues, security conflicts, and sometimes in a conflicts there was some access control policy was wrong, or unintentionally we have blocked the communication, something we can do wrong. Okay, so now, or maybe some natural disaster happened. Okay, so basically now what happened, there is no communication between these two components. Yes, so as everyone understood this much, there are two components, two databases. Earlier they were communicating with each other to make sure that we are able to synchronize and the data is same, the data is consistent on both the databases. Everyone understood this? Angad, have you understood this much? Those who are asking to repeat. Have you understood that there are two databases and we need to talk to them. They both need to talk to each other. They both need to synchronize the data with each other, right? Now what I say is that now they are not able to communicate with each other, say because of some network failure. Now I am saying that in one case data will not be consistent and in one case it will not be available. Let's say when the data is not consistent, what happens? Why is it being inconsistent? Why am I saying it is inconsistent? Because suppose the write happened over here, the data was updated from 100 to 200, but now read has happened over here. Because I was not able to tell this database that the value has updated, right? There's no communication happening. Because there's no communication happening, this database has what? It has stale data, old data. It doesn't have the latest data, right? So that is why it is returning me wrong data. So it is inconsistent. Okay, like we discussed, right? So in systems like banking, ATM, we cannot afford this. We cannot afford our data to be inconsistent, right? So we thought of another solution. Another solution is that if I am unable to talk to this database, what am I going to do? I'm going to make sure that, okay, this database stops responding. So maybe in the response of the write, I tell that, okay, we have not updated this database. Probably you stop, taking requests from this database or something like that. Some mechanism we have make sure. So now what happens? A system is not available. So when we have partition, I am trying to say that we can either have a consistent system like this, or we can have an available system. So either our consistency will go for a toss or our availability will go for a toss. Has everyone understood this? Yes. And you just understood a very important concept of system design, which is called CAP theorem. It is extremely, extremely important part of system design. Okay. Now let's try to understand what CAP theorem says, and let's see how you have already understood this. Okay. C stands for what? C stands for consistency. A stands for what? A stands for availability. P stands for what? P stands for partition tolerance. Okay. What does CAP theorem say? It says that in a distributed system, you understood what a distributed system is? Basically, components communicating over network. We understood what a distributed system is, right? In a distributed system, out of these three requirements like consistency, availability, partition, tolerance, you can support or achieve maximum two of these three properties or requirements or whatever you want to call it. It is impossible to guarantee all three at the same time. What does it say? It is impossible to guarantee all three at the same time. Everyone understands this? So we will discuss this in detail. Whatever questions you have, we will understand. Is this a mathematical theorem? Not exactly, but we will understand that how this makes sense. This is a logical thing, basically. Okay. Before I explain this in detail, let me just say it out that, this oversimplifies things. Whatever this says, we will understand that, it means that either we can have 100% consistency or availability or partition tolerance. And let's try to understand this in detail now. Okay. Quick revision for you to be able to understand CAP theorem. What is consistency? What is availability? What is partition tolerance? Let's do a quick revision and then we will move ahead. Like we'll talk about CAP theorem. Okay. We started with firstly understanding what a distributed system is. We talked that, okay, whenever communication is going to happen over network, it is a distributed system. Very simple stuff. We talked about that, okay, there will be single point of failure if we have only one server or only one database. So we want some backup, right? We want some backup. Otherwise, our system is not going to be what? It is not going to be available. So now we talked about that, okay, data is going to be available, say, on three nodes of the database of three databases, right? So there is some backup. Now, because we need to copy the data, now write is going to happen only in one of the databases, right? We need to copy the write to the other databases. Now, in order to copy the write, we need some sort of synchronization between these databases. So we need some sort of synchronization. Let me use this. So we want some sort of synchronization between these databases. So we need time for this synchronization, right? So because either we can have like see, if we do the synchronization before returning the response, what's going to happen? Our response is going to get delayed, right? So either we can do it synchronously or we can do it asynchronously. What does synchronously mean? It means that before sending the response itself, I'm going to update these two databases, right? Synchronous, I'm going to do it at that time itself. Synchronous replication, I'm going to replicate it at that time itself. But what happens, because I'm going to replicate it, my system is going to become slow. My response is going to become slow. But what am I going to achieve? I'm going to achieve strong consistency. How am I going to achieve strong consistency? Basically, whenever request comes from any of these databases, I'm always going to respond the correct data. So that is why I'm achieving what I'm achieving, strong consistency. Now, in case I do not want synchronous replication, because suppose time is a better thing that I want, what am I going to do? I'm going to respond yes. I will say that, okay, I've written. And after responding, I'm going to synchronize or I'm going to update these two databases. Now, since I'm doing it after responding, the data will be updated, but not immediately. So data will be consistent, but not immediately. So it will be eventually consistent. So this is what it is, just different levels of consistency. So this was what it was, strong consistency. This is what it is, eventual consistency. Everyone understands this much? Yes. So we have talked about strong consistency and eventual consistency. Then we talked about that in every interviews, there will be something called functional requirements and non-functional requirements. The functional requirements will be basically functions that you have to perform in a system. As the name suggests, non-functional requirements will be properties that we are discussing, like consistency, availability, partition tolerance. These are what? These are properties of the system, or you can say that quality of your system, that how your system performs, right? It tells that how is the system performing. So that's called a non-functional requirement. Correct? Everyone agrees to this. So now we discuss consistency. Second thing that we discussed was availability. In availability, we discussed that there are different levels of availability. It is mentioned in your service level agreement. There is something called 2 nines. Basically, your system is going to be down for 87.6 hours per year. Then there's 3 nines, there's 4 nines, there's 5 nines. So basically, every system, even if it is like a distributed database, it will tell beforehand that, okay, our system provides this level of performance, or you can expect this much downtime or this much uptime. So basically, beforehand, you are testing a system, you're simulating a system, and you know that, okay, what are the chances, or worst case, what is the maximum amount of time that we can commit that, okay, this is the level of performance we are going to provide. What is it we discussed? We discussed that how can we improve the availability of the system. Now there are different ways. There's replication, scaling, geographical distribution, load balancing, failover mechanism. We discussed all of these ways to do what? To improve the availability of the system. Everyone understands this? Then I said that, okay, we have understood consistency, we have understood availability properly. Now what we want to do is we want to make a system both very, very strongly consistent and highly available. Is it possible? Then we talked about that now for the data to be present in the both of these databases, we need these databases to communicate with each other, right? But say because of some network issue, there's a partition. This is called a network partition. Some partition happens and the communication between these two nodes is now broken. Now what happens? We discussed two cases. Either what we are going to do, we are either going to make sure that, okay, we want the consistent data. In that case, what I'm going to do, I'm going to stop taking requests, read requests from this database. But if I stop taking requests from this database, what am I doing? I am saying it is not available. Over here, what I do, suppose I say I want my system to be available. What am I going to do? I'm going to write over here the value was 200. I read from here the value was 100. Now what happened? The system turned out to be inconsistent. So see, we talked about three things. We talked about availability, consistency, and partition tolerance. And if you think about it, here what was happening is partition was happening, right? We were trying to make a system what? We were trying to make a system partition tolerant. So if partition happens, what are we going to do? There are two ways to deal with it. Either we can make a system highly available, which is like this, or we can make a system highly consistent. We will give what we will trade off what we will trade off availability, right? And that is why system design is famous for what? We should be able to discuss and understand the trade-offs. We should be able to understand that, okay, either we will give up availability or we will give up consistency. Everyone understands this? No, partition is not only for DBs. Network partition can happen literally between any two components, right? That is why in the starting I said we are talking about distributed systems. We are understanding with the perspective of databases, but any two systems, like any two components, distributed file storage, file system, or tomorrow we are going to learn Kafka. That is also a distributed system, distributed messaging system. Same thing is applicable to everywhere. You can have maximum of these two things, like maximum two of these three things: consistency, availability, and partition top. Okay. Now, my question to you guys is, can we have, say, consistency and availability in any system? And so technically, the what does the definition says? It says that I can have maximum two of these three properties. Now, what are the three properties C and P? I said like over here we made a system partition tolerant. So here our system was what? It was available. So it was sorry available. So A. So let me write that out. So actually you will see these terms. So if it is available and if it is partition tolerant, it is AP system. You can see this, right? It is AP system. So it is available and it is partition tolerant. Over here, our system is consistent and it is partition tolerant. So it is a CP system. Okay. What are we going like here? What has gone for a toss? Availability has gone for a toss. Over here, what has gone for a toss? Consistency has gone for a toss. Correct? Now, can I ever have? So AP is possible, CP is possible. There are three things, right? So there are three combinations. Can I have CA? We talked about AP, we talked about CP. Can I ever have CE? Can we have answers? So people, some people are saying yes, some people are saying no. How many of you say yes? Can I quickly get more yes and no's? So my question to you is, can we ever have consistency and availability and not partition tolerance in a distributed system? Very good. So for those who are saying we can have in a monolith or a single system, not in a distributed system, very good. Yep. As long as it has no partition means it is not partition tolerant. No. So why can we not have it in distributed systems? See, theoretical you can have. Suppose I can argue with you that suppose there are these two databases, they are connected over network. I will make sure they are connected over a backup network. Suppose some natural disaster happened over this network. There's probably a longer route I've connected over like this, or I have a backup network which is running. So I can say that I have made my system what now like P has gone like I will make sure that I'm supporting CNE, right? You could do this, right? You're making sure that partition tolerance never happens. Correct? That partitions never happen. So we're having a backup network. See, what is the definition of partition tolerance? Someone is asking. So basically, we talked about partition being happening, right? So how much can you tolerate the partition is the easier way to think about it. So network partitions, just think of it like, so when I say partition tolerance, I am saying that here my system, like partition is never going to happen. So if I want C and A, I am going to support partition tolerance means partition is never going to happen. Can I have that? That partition never happens. I could probably have a backup network. So theoretically, you can have that have many backup networks. But what is the problem that happens over here? Problem is obviously cost. Imagine a distributed system having at multiple geographical locations. Cost is not possible. It is not possible to have multiple networks for every particular connection. Correct? Yes, infra cost. So that is why theoretically it is possible to have CA system, but in reality, in a real distributed system, it is not possible. Okay. So in an interview, the first of the few discussions that is going to happen in system design, when you discuss requirements, you're going to discuss functional requirements and non-functional requirements. When you discuss functional requirements, the question that is going to come to you is that what are you going to trade off? Is it going to be consistency or is it going to be availability? Availability. Sorry, I don't know. Is the spelling wrong? Maybe. So consistency and availability. You can trade off. You can have only one of the two because partition is going to happen in a distributed system. That is something that is not in our control. It is a network failure. We discussed it can happen because of network congestion also. We cannot completely avoid it. Okay. So you can either have consistency or availability. Basically, you will have to trade off one. You will have to prioritize one of them. Obviously, you would want that as consistent as possible, as available as possible, but you would have to prioritize one. Yep. Has everyone understood this much? I'm going to take a 1 minute break and just read through all the questions that are there. Can't we have network backup in microservices? As I said, infra cost. Strong consistency, more chances for partition, less availability, less consistency. Okay, good. Okay. So yes, partition is inevitable. So you all have understood this much. Yes, everyone is understanding till now. Any questions till now? Okay. Now let's do something interesting because too much theory for the day. So let's take some examples of the system and let's try to understand that, okay, what are we going to support? Consistency or availability. Someone is saying, can I take 2 minutes to digest this? Okay. See, we learned three things: consistency, availability, partition tolerance. We are saying we can have only two of these three things, and we actually saw it also, right? Now, what happens that we are saying that partition tolerance is something that is out of our hands. It can happen because it will always happen. If I try to support availability, my consistency is going to go for a toss. If I support consistency, my availability is going to go for a toss. So I'll have to prioritize one. See, in CAP theorem, what happens is we oversimplify it, and you will hear architects talk about this a bit. here in CAP theorem, we are saying we will either have 100% availability or say 100% consistency. The truth is that, we are oversimplifying it. Suppose we do not want 100% availability, 100% consistency. Suppose we are happy with say 80% availability, 80% consistency or something like that, some percentage, right? In reality, we would not want 100% availability and let consistency go for a toss, or 100% consistency and let availability go for a toss. So now that you have understood the concept, we will take examples and we will understand that why it is okay to trade off and understand that, okay, here I want to prioritize availability or I want to prioritize consistency. Yes, so this discussion is not black and white. You are prioritizing one. It is not like you are letting go consistency altogether, you are letting go availability altogether. Here what we are doing is we are choosing that, okay, given a condition, what is more important to us? And for that, let's actually do the discussion. So I'm going to give you, okay, this is a quick exercise. I want everyone to be, to be here with full attention. Can everyone hear me? Is everyone here? Can I quickly get yeses? Thumbs up. Yes. Awesome. So we are going to do a quick exercise now. I'll take a lot of system examples and we will discuss that for every system, what is more important, consistency or availability? Okay. Sandeep is asking, is there partition tolerance? How can we stop the other server to respond for achieving consistency? I didn't understand the question. If there is partition tolerance, firstly, we said it is not possible to have partition tolerance, right? Okay, let's say it is possible to have partition tolerance. Let's quickly take that example. So let's say that, this system will always be connected. Then it is possible, no? Then we can just synchronize at that time itself and we can respond. So we will have strong consistency and high availability. But it will be matter of few seconds that, either our availability will be like, we might have to like wait for say 1 millisecond, or we might have to like, give stale data for that 1 millisecond. So we'll have to decide accordingly. Yep. Okay. Let's take the examples now. Okay. Consistency and availability. Cool. Let's start with the example of say YouTube comments. What is more important for YouTube comments, consistency or availability? You can just say C or A also, consistency or availability. Manish is saying consistency. Why is consistency more important? Okay, most of the people are saying A. Correct. See, if you're going through YouTube comments, just imagine you're watching my YouTube video and over there you go to the comments. It is okay if you don't see the latest comments, right? But what happens, what will your user experience will be if you cannot see the comments at all? Obviously, availability is more important, right? Just imagine, like in terms of user, you go to YouTube, you are trying to check out the comments. Obviously, you should be able to see the comments. It is okay if you're not able to see the latest comments. But what is more important? Availability is more important than consistency. Correct? Yes. Now, let me give you another example. Say Insta post or feed. So I've posted something and okay, so what is more important over here, C or A? Are you just copy pasting the same thing? Shanawaz is saying consistency. Venkatesh is saying consistency. Okay, Shanawaz and Venkatesh, whoever is saying consistency, just imagine opening Insta and not seeing any feed or not seeing any post, right? That should not happen. It is okay if the post comes after 2 minutes. It is okay if you see the latest post after 1 minute or 2 minutes or in milliseconds, but it should be highly available. So A is the most important point. Correct? Let's take another example. Amazon cart. I have asked you to design Amazon cart. Okay. Now Amazon cart, what is more important? Consistency or availability? I can see a lot of C's. Very good. Can someone tell me why consistency is more important? See, both are important, yes, but we have to prioritize one. See, suppose you updated something in cart and you're not able to see it. You refreshed it, you're not able to see it. You will add it again. You might end up placing an order for, say, 2 items. That is not okay. It is okay if you cannot see your cart for 1 second or 1 minute, also, worst case. It is taking time to load, right? But here, because your money is going into picture, like, you're making a transaction, you cannot afford to place two orders or, not order anything. Suppose sale is going on and suppose you deleted, like, someone else deleted it from your account and you can still see it. It is not consistent. That's not a good user experience. It is fine if it is not loading, but you should see correct information. Correct? Yep. Okay. Let's say, what about, okay, let's take an example of Uber. Now, in Uber, what is important, availability or consistency? I am waiting for the correct question. Very good, Soham. Thank you so much for asking this. All of you are saying consistency and availability. What part of the Uber are we talking about, guys? Here you can see, YouTube comments, Insta post or feed, Amazon cart. For which requirement? Very good to those people who asked which requirement. How can you simply say consistent availability? What were you assuming? What feature am I talking about? What requirement am I talking about? Scope. Very good. This is how you start thinking about system design. Think, guys. You're not supposed to just randomly answer. Think before answering. Yes, there can be multiple cases. Okay, some people are saying booking. Suppose, okay, now suppose I am saying payment. I did not mean booking, I meant payment. Very good. Srijan has actually mentioned it. Payment, consistency, rest availability. So for payment, consistency is more important. But for, say, search or booking, what is more important? Availability is more important. It is okay if I do not see, a driver who just came. Maybe I do not see the latest updated data. Maybe it is not very consistent. It is fine, but it should be highly available. I should be able to search for cabs. But in payment, what will I do of availability if it is not consistent? My payment will go for a toss. Yes, never. I do not want any of you to make the same mistake ever again in system design without asking the correct question. Do not start answering availability, consistency. Do not. I was very surprised by the number of answers that already started coming in. A and C. Why is booking? See, booking is not C, booking is availability. So booking is availability. You should be able to book. Availability is important. Booking right should be C because two people should not be able to book. So here basically I meant search. If you see about, yeah, selecting the Uber, then yeah, you can say booking. If you had talked about booking in a Book My Show, I would have said consistent. But here I meant search. So I said available, right? Very good for pointing that out. Yes, Uber booking can have issue with it. Yes. Yes. So if I would have asked Book My Show, if I would have asked Book My Show booking, it would have been C. Here I was talking about searching. That's why I did search and book. Sorry, guys. But glad that you're thinking about it. Let's take more example. You guys are doing hackathon, right? Let's talk about WhatsApp. What is more important in WhatsApp, consistency or availability? This is an interesting point. Consistency or availability in WhatsApp. Okay, so this is a confusing thing, I think. Which feature in WhatsApp? Okay, let's say sending message. Yes, chats. Let's avoid. Very good for asking the question. I'm not talking about payments. I'm talking about messages, messaging. I can see a lot of mixed reviews over here. Okay. So for those who are saying availability, let's try to, because there's a lot of mixed response. There's availability, consistency. I can see a mixed response over here. Let's say there is consistency. Let's say there's availability is the point. Okay. Now, suppose I check a message and it is not there. I will resend it. I will resend it. Or suppose I check my history and I cannot see the recent message, it is not a good experience in WhatsApp, right? As soon as I send something, I want it to be consistent. I should be able to see the same data everywhere, right? But you could argue that I want availability is the more important thing. WhatsApp should never go down. So sending message consistency, status or last seen, someone is saying Nimisha is saying availability, stories you're saying availability. See, if I talk about chat, if I talk about messaging, you should discuss with the person who is giving you the requirements. Or in this case, if you are the one who is deciding the requirements, at least for say hackathon, you should decide it yourself. We should know the trade-offs of any system. See, I would personally go with consistency. Why would I go with consistency? I should see the same chats everywhere. It is okay if I don't see the chat or if it loads for say 2 3 seconds, but I want the system to be consistent. I want to see the same chat everywhere. Okay. You could argue and you could say it is okay if the chat, it is eventual consistent. I want it to be highly available. Again, what are we doing? We are talking about trade-offs. We are making design decisions. We are deciding our requirements. Does everyone understand this? That now you are talking about trade-offs in a system. Yes, I would stop using WhatsApp if not available. No question of consistency there. True, it is your point of view. But if I see the trade-off, for me, I would stop using WhatsApp if I don't see the consistent messages. If I am resending the same message, suppose I'm sending message to some big guy and I end up sending the same message 3 times because I thought, "Oh, okay, it is not being sent. I would stop using it. Or suppose I sent a message, now I cannot see it in history, or maybe it gets lost. Yes. So depends on your design decisions. Yes, being not available can mean WhatsApp is down, or it can just mean it is buffering. You can handle it in a graceful way in the UI, right? So you could actually buffer it out. Yep. Okay. Let's take one more example. ATM. ATM, I guess everyone will be able to answer. ATM, what will be the thing? Consistency. Someone replied that in WhatsApp we can do read your write consistency. Very good for thinking that. Yes, ATM will be consistent. I think everyone wants that. It is okay if ATM doesn't want. I want my thing to be, yeah, money wala system. Yes. Good question, Pratima. Very good. Can we discuss WhatsApp user active status? So if I talk about status or active status, what do you think? Should it be available or consistent? WhatsApp active status. Available or consistent? There's a lot of mixed reviews, mixed feedback. Confusing. Yes. This is why in system design interviews it is very, very important to have good communication with your interviewer. I would personally want availability in terms of status. I should be able to see it at least. It is okay if I can see, sometimes it happens now that we see the online offline status say after 1 minute, or we see it after 1 minute is fine, right? So it is fine if I don't have it consistent. For me, availability is the most important thing. It should work. But again, this is very, very subjective. You can design your system in a particular way, and you have to discuss the requirements with the person who's asking you to design. And these are the kind of things that we discuss. Like, so basically, consistency versus availability, this is something that, uh, architects decide on the basis of a lot of factors, like, what is the competition, your competitive products, what are they supporting, based on some analytics, based on user data, based on a lot of things, right? But basically you understand that you have to make a trade-off decision, correct? Let's take one last example, probably file sharing. Suppose say Google Docs or Google Exit Sheet that you guys are using, say for hackathon, right? Suppose I go and assign you in group one, and you were trying to assign yourself to group two. And then what will happen? Yes, for me, consistency is more important over here. Why is consistency more important? If I am writing something, I want you to be able to read that only. Suppose I write something and then you update, now I can't see it, I rewrite it. A lot of issues can happen. Correct? So I want Google file sharing to be consistent. Yes, it should be same for everyone. So has example for partition. What example for partition do you want? Basically, network partition is happening. No? What do you even mean by example of partition? Yes, it depends on the type of data. Okay, I'm reading through questions for a sec. If I have a question, I have a question. If a user sent a WhatsApp message, user phone cache always shows the message. The receiver would be okay not to receive even for a few seconds. He need to be able to see the older chats even if he doesn't have the new chats, correct? So here basically you're talking about the user side of thing. But yeah, that means that you are seeing the data. That is just latency. That is not consistency. That is latency. That in how much time is your data reaching over there? Yes, but it should be available in that case. So in messaging, you are talking about sending messages, receiving messages, probably going through history. If you talk about history, see, I suppose I'm not messaging right now. I'm just checking the history. Can you at least agree that I should see the same history on my system, on your system, on receivers and or whatever? You should be able to see the same thing. Actually, in WhatsApp, when you guys design for hackathon, these are very interesting points, and you should think about it. See, suppose something interesting to think about. Just think about it. I send a message. No, sorry. I receive a message. Say I receive a message at say 10 p.m. Okay, I receive a message. Hi. I respond at say 10:01. Okay, this guy was sending hi, starts typing something, something, something. While he is typing, I already sent this message, right? Now, while I send the message, maybe this message is also on the way, this message is also on the way. Now, for this user, what will happen is that this message will, you will be able to see this message before and you will be able to see this message after that. But in this case, what will happen is you will be able to see these two messages together and this message later. Someone muted me. Okay. Stop muting me, guys. Stop muting me, please. Okay. Yes, so there is a conflict resolution. Here, what we are doing basically, here we are sending the message. So one message, then user two's message, then user one's message again. Over here, what we are doing, user one, and then user two. You understand? So now same history. What do you think? What does user do? So what does WhatsApp do? In WhatsApp, actually, there are two versions of the history that is mentioned that is there. Now, uh, in any device that I log in for my WhatsApp, I should always be able to see this history. In any device that this user logs in, this user should be able to see this history. So this is actually very interesting concept that we should discuss. So there's something called history, and then when you're sending the message, what time you're sending, like receiving. Yeah, so it could be dependent on timestamp. So these are small things that now I want you to start thinking of. Cool. So basically, there is no right answer. It is subjective. Yes, in system design, that is mostly the answer to most of the questions. Okay, it is 10:48, guys. Can you all stay back for say 5-10 minutes today? We wanted to cover a few more things after cap theorem also. So we learned few jargons today, right? Consistency, availability, partition tolerance. So quickly, let's discuss a few more jargons that you will hear a lot in system design. Let's do that. Everyone with me, everyone awake. I hope you enjoyed this. I hope you are now you feeling that you know system design. Can we move ahead? Yep. Awesome. Thank you. Cool. So, okay, can one of you quickly tell me what is latency and what is throughput? I'm just talking about jargons that you will hear a lot in system design. So I'll quickly cover them. What is latency? What is throughput? Latency is basically you initiated an operation and the time that is taken for the operation to complete. So basically, when you initiate, you start, and then in order to finish it. So when we say latency of a request, so basically how much time it took. So when you send the request and when you came it, the time taken or the time delay comes under latency. Yes. Yes, very good. I can see most of you already know this. So throughput is what? This is rate at which basically the transfer happens. data, it can be data or task or basically anything, rate at which task is processed. So basically, this will be what? This will be in terms of say per second or per hour or per minute. Basically, this will be in terms of time. So per unit of time, what is happening? So for a given, so it will be for a given time frame. Everyone understands this, right? Latency and throughput. Yes, number of requests processed. Yes. Can you give example of throughput? So like Mbps, when we say uh, how much, how many megabytes or how many megabits you are transferring in per second. So Mbps, Bps, this is all throughput. In per second, how much data you are able to transfer, right? Latency would be like say seconds. I took this much second to send this data. Throughput and bandwidth. Uh, Good question. Bandwidth is sort of throughput. You could say that. You could say it in terms of networking. Yes, you could say it. I think so. I will check it again. I think you can say it. Bandwidth is basically how much data you can send in a particular time frame. So it is sort of like throughput. Yeah. So the amount of data per second, right? So that is throughput. Yes. Cool. Uh, One more thing. It is different words. There we are talking about amount of data, but because it is per second, you can actually thought of it. You can think that it is the same concept as throughput. Yep. Okay. Another question, another word that you should know about fault and failure. Can someone tell me what is fault and failure and what is the difference between them? And in distributed systems also. Can you tell me fault and failure, guys? Fault is one component down. Fault is wrong data. I'm just reading through the comments right now. Fault is when we have unexpected results. Very good. So any abnormal behavior, any, anything that goes wrong is basically fault, right? Any error, any communication that happens is fault. Then what is failure? Fault lead to failure. So basically fault leads to failure. Basically, system can't provide its intended services. That's called failure. Failure happened. Or you can say fault is the cause of failure. Just technical terms. So after today, I wanted to talk in system design ka terms. That's why I'm introducing all the jargons to you. Like since we have already discussed consistency, availability, partition tolerance, all of this, right? Fault is not studying for the test. Failure is repeating the class. Very good. Failure is failing and fault is not studying. Yes, very good. So fault is basically error that happened, any communication problem, anything else that happened, that is fault. Fault led to failure. Very good. Very good example. Okay. Uh, this much is clear? Yes. Can we move ahead? Another term that you will hear is resiliency. Can someone tell me what resiliency mean? You would have heard how resilient is your system. I want to talk about resiliency. What does resiliency mean? Recover from failure, ability to withstand failure. Very good. Fault tolerant. So basically your system, how much it is able to recover or bounce back. So how much it is able to recover, bounce back from failures. So basically resilient system, when someone is saying what does resilient system means, that it is fault tolerant. Yes, it is fault tolerant. It can continue to operate even when certain components fail. So basically there will be some recovery mechanism. So if something has failed, maybe there will be some automatic failover, there will be backup, there will be restoration procedures, something, ways to do it. Okay, I'm just introducing the terms right now. These are what? These are basically terms that are used in non-functional requirements. That your system should be resilient, it should be fault tolerant, failure should not happen, all of this. Okay, can I move ahead? How do we measure resilience? We we will discuss this in detail. We will discuss this. How do we measure? You could probably There are ways to do it. I don't want to get into the details right now. There's less time. We will discuss this. Not we will discuss. Cool. Another term that I wanted to introduce, redundancy. We already talked about this today. What does redundancy mean? Replication or duplication of same data. Right? We had talked about this. We can have redundancy at various levels. It can be at, say, hardware level. It can be, say, they can be, say, data redundancy or data storages. They can be network redundancy, sorry, residency, okay. Redundancy, then there's service redundancy and all of that. Unnecessary duplication. Okay, cool. Has everyone understood these terms? Do I need to quickly revise? Everyone understood CAP theorem, consistency, availability, partition tolerance. We said we can support only two of these three, and then we said that in distributed systems we cannot have partition tolerance systems. So we would either have to prioritize consistency or availability. Then we talked about that. Then we talked about latency, throughput, fault, failure, resiliency, redundancy. I'm just introducing all the terms to you. Okay, it is okay to get confused right now, at least for beginners. But what is going to happen is we will get used to using this so much in the future classes that you will get used to this. Okay. Last concept of the day, and then we will talk about hackathon, and then you can go. Okay. Last concept of the day I wanted to cover. Not yet. One more thing left. We hear stateful systems and stateless systems. So someone had asked about this also today in the Discord channel. So there's something called stateful systems and there's something called stateless systems. Can you tell me the difference? So Rajni is asking for examples for fault, failure, and resiliency. See, we will discuss it in detail. Right now, I'm just introducing the concept, but quickly giving you some example also. Like, for example, some network failure happened, like over here. So two databases were there. Suppose partition happened, network happened. So this what happened? Fault happened. But how do you recover from this? Either you stop using this or you return stale data or something. That's called what? You are recovering from the fault that happened. So you're saying your system is fault tolerant, right? Suppose you did not do that. Suppose both the databases stopped working. There was no communication. A failure would have happened. So your system did not work properly. Okay. Okay. Stateful versus stateless. I'm going to the comments. Um, Stateful stores the client details. Stateless doesn't store, only focuses on response. Stateless system has to depend on external. Static website is stateless. Very good. Stateful system will have some data. Okay. Very good to everyone who has said. For beginners, I'm going to explain it right now. Don't get overwhelmed. They also know a bit only, just one line that we will know now, and you will be also able to answer. So beginners, relax. We are going to discuss now. Okay. In stateless, basically what happens that when a request comes, no, it has all the information. It is basically an isolated transaction. It is not dependent on any previous state or any previous data that was there or any previous request that came. It is treated as an independent and isolated transaction. Okay? So that is why that is stateless. Okay, so server is not storing any info about the previous transactions or client's state between the request, nothing. So basically each and every request contains all the necessary data and context required to process that particular request. Okay, REST APIs are stateless. Yes. HTTP is stateless. Yes. What WebSocket is stateful. Very good. So what is happening over here is that in stateless, I am saying that each request is going to have all of the necessary data content required to process it, and the server response based on the request that comes. Okay. Stateful is going to happen what? That we are going to maintain or store. We are going to store some info, and then we are going to they make decisions accordingly and send the data. Okay, we are going to respond accordingly. Okay, everyone is saying that all HTTP is stateless and request, yes, but let me give an example, like in a system. For example, you are doing auth. Okay, we are doing auth, and you usually create a session and you store session keys, right? Now, corresponding to this session, suppose I have some data stored. And based on this data, I am responding to next request. Then what do I call my system? I call it a stateful system. I'm sort of giving a personalized experience because I have this some information stored of this user, right? Yes. So in stateful, what am I giving? I'm giving personalized experience. Very good example. Shopping cart. Shopping cart is a good example. So basically it is there and I'm responding accordingly. Yes. So that is stateful. Okay, I can already see a lot of advantages, disadvantages. So I'm just going to note it down over here. In stateless, what are the advantages? Can someone tell me the advantages in stateless? It is simple to understand, implement, very simple, right? What else? It is scalable. I can already see this is scaling. Yes, very good. Why is it easier to scale? Because every single request is different, right? So you can just scale it. Some requests will go to this, some requests will go to this. Versus here, scaling is going to be hard. Why? Because you must have stored the data on this particular server, and now you want to send the data to this server because this server is overwhelmed. So what are you going to do? So it is complex to maintain, right? So these are the advantages. Can you tell me disadvantages of stateless? What are disadvantages of stateless? We would have to send the same data again and again because every data, like every request, you have to like send the entire information. Love is saying cannot personalize. Yes. So we'll have to send the entire thing. We might have to send redundant data transmission, right? Redundant data transmission. Yes. What else? We have to repeatedly send the same data, no personalization. Here, what is happening? Here, what are the advantages? Can someone tell me the advantages of stateful? It is efficient. It is personalized. Yes. What is disadvantages? As we had already discussed, it is complex to handle. Very good. What else? Scalability. We already discussed this. Scaling. Sorry for the horrible handwriting, but yeah, cool. So this is all I wanted to cover today. But before we end the class, I want us to have a quick 5-minute discussion of what you're supposed to do in hackathon. So hackathon, again, I'm going to repeat it. It is not compulsory for you to participate, but if you can participate, the learning process is going to be much more fun and interesting because you will actually apply the concepts that we discuss. Okay, we will do the quick revision of the class as well, but some people might have to go. So that is why I will quickly cover a bit about the hackathon because we decided over the weekend and some people might have a lot of doubts. So we'll quickly discuss how to even proceed with the hackathon. So initially right now what you can do is you will have a local server. Yes, and you will write some client code. Now, a few of you might be like front-end engineers, and you can make sure that you can, make this look good and all of this. You can do that. I don't care much. You can try it out, but I don't care much. I want the system to work properly, and that is what I care about. Okay. So now what you're going to do is write some client code, write some server code, and you're going to send WebSocket you're going to make a WebSocket connection and send some data, right? So this is the first thing that you will do. Now, after this, what you will do is you will probably send data and you will see that communication is happening over WebSocket. After this, what you will do is you will make another client. Another client meaning what? So same data is going to be over here. Just say username is going to vary. So say right now, guys, focus over here. You can connect with each other over Discord later. Just focus over here. You will be able to understand what to do in Hackathon. So if suppose the username was say A, here the username is B. Suppose you can make it dynamic or something. So same code should be running on both the clients. Now do what from this local server? Try to communicate that, okay, suppose do like send message to B. And here you do send message to A. Okay, this much you should be able to do right now because we have discussed networking and we have discussed WebSockets, correct? And this is very simple to do also. You can actually, with ChatGPT, you can just search and you'll be able to see the code. But if you're not able to understand, then you can ask. WebSocket, you can see like the code in the library. It will be very easy. You can do it in any language that you want. But if you have any questions, ask on the channel. Okay. So now what you will do, first you have two clients, you will make them communicate with each other on the local server. If you want, you can probably do with more clients. Suppose say client C also, and what you can do, you can try to broadcast the message to client A and client B. You can try this also. Okay. After you are done with this much, what you will do, you will make an AWS account. Whatever we use in AWS, we will use the free stuff. We will not buy anything. Okay. So create an EC2 instance and host your local server over here. So your server code will go over here. Now do the same thing that, okay, your client is over here. So there will be a public IP over here. Okay. And just send the message and do the communication through WebSockets. Okay. Over here, just remember for those who will be using EC2 instances for the first time, EC2 instances, use the free ones, shut it down after using it. Otherwise, billing might start. Don't waste any money on this. Use free tiered EC2 instances, everything free. Okay. Now what to do that, okay, uh, you have done this much. This at least you should be able to do by the end of this week, right? This week we will discuss Kafka. We will add Kafka. We will discuss load balancing. We will add load balancers. Okay. So form the groups. Try doing this. I'll give you time till tomorrow because some people are still forming the groups. Try to form the groups. And if you have any questions, ask on the channel. I and like the Jelly Bean guy on Discord, we will be there to help you out. Okay. This much you should be able to do. Just make a WebSocket connection, send message, because when you actually apply these concepts, it will be much clearer. It will be much more fun. And host the entire thing on GitHub. Like five of you are like what, how many ever people are there in your group. There should be one GitHub link, or you can have like copies of it. I don't care. Share one GitHub link on that Excel sheet or on the doc sheet, and I should be able to see the GitHub and I should be able to see the code. So everyone else can also refer. We can learn from each other. And by the end of the course, we will have a project ready. We will make an entire video with one of the groups where we are explaining the entire system step by step what you did. Okay. Repeating it quickly because some people are saying we write one client code, one server code, make a WebSocket connection, send some message. Write the same client code, just different username, and try to broadcast the message to different clients. Okay. Once you are done with this much, create one AWS account, host one free EC2 instance, host this server over there, and because this will have a public IP, try to have a WebSocket connection there. Cool. Whoever is still finding group means just message on Discord. Worst case, tomorrow I will auto assign the groups. Tomorrow, end of day, if you don't form the groups, I will auto assign the group. Cool. Okay. Can we do quick revision of the class? Yes, everyone with me? Cool. Quick revision of the class. Okay. So we started with distributed systems. We understood that, okay, there are different parts of the systems. We need to have replicas of, say, servers, databases, and different systems, different components of the system. Let me use this. Okay. Then what did we do? Okay, I'm just seeing the bank example, consistent availability was somewhat confusing. Okay, we'll take more examples. Cool. We want to avoid single point of failure in distributed systems. So we talked about replication. Then what we did, we talked about how we can have consistency and the levels of consistency. There is strong consistency, there is eventual consistency. In strong consistency, what we can do synchronous replication. Basically, add the data before acknowledging the write. So what will happen that, okay, data will always be latest before any read comes. So your write will not be successful until you make sure that, okay, data is latest on all the databases, on all the nodes. Over here, eventual consistent means what? That, okay, I acknowledge my write, and after that, I am going to sync my data, or after that, I'm going to copy my data or replicate my data. So for some milliseconds or seconds, you might get stale data. Yes, everyone understands this. Replication leads to redundancy. Yes, because you have the same data kept on this database, and this database. Yes. Then we talked about functional non-functional requirements. When we actually start looking through the systems, we will discuss the functional and non-functional requirements in week 5 in detail. Today, we discuss a lot of non-functional properties, basically, the behavior that you would want to support in your systems. First thing we learned was consistency. Second, we learned was availability. And availability, we talked about that, okay, the system should be operational or accessible. Then we talked about the nines notation, two nines, three nines. We talked about SLA. Cool. We talked about how to increase the availability. Then we talked about partition. Now, what is partition? There's basically network failure or network congestion, routing issues, whatever. Basically, your two components are unable to talk to each other. Partition has happened. Okay. Then we talked about that, okay, if a partition happens, then either I can support uh, availability. So I am supporting what? I am supporting availability and partition tolerance. So my system is inconsistent. I am letting C go for a toss. Here I am letting availability go for a toss. How I am letting availability go for a toss? Because I'm going to stop taking requests from this database. Here, how am I going to like how am I letting consistency go for a toss? Because here the updated data was 200, I was reading 100, right? So here the data was inconsistent. Here the data was not available, right? Then we discussed that out of cap, we can have at max two properties support. We cannot guarantee all three at the same time. So when we said that we can have at max two of these supported, we know that we cannot make our systems partition tolerant because network failures are out of our hands. Network failures can happen. So now we have to prioritize between what? Consistency or availability. We have to make a decision. There are trade-offs, right? You can have like percentage of both, but you have to prioritize one over the other. There's always a trade-off, right? So here then we took some examples that, okay, in what consistency is important and what availability is important. Then we learned some more jargon words today. We will see these jargon words that I covered today. We covered in very, like, very quickly, right? We will discuss it in much detail. And when we use it so much, you will get used to it. Okay. Latency, throughput, fault, failure, resiliency, redundancy. Just understand the basics. You will understand them completely. You will get used to them when we start talking about the systems. Okay. Then we talked about stateful and stateless systems, and we talked about the hackathon, and that is it. I hope you had a good class, week 2. I am sorry for the initial confusion. I saw a few mails that were coming during the class that one or two people did not get uh, the link, and I hope they are okay. But I hope you're happy switching to Teams. Now we will have all the classes on Teams. That is final. So I hope this is sorted. Yes. If anyone wants to take pictures for Insta or LinkedIn, this is the time. I don't know what to open right now. Cool. Yes. Now I am available. We can probably talk or whatever you guys want. Now you can even unmute yourself, talk, whatever chat, whatever doubts you have, just ask anything. Yes, I will send the invite links over mail. But a bunch of you have added wrong mail IDs. Please update your mail IDs on the site, or you know I will be anyway sending the link on Discord as well, so you'll be able to attend. Okay. When will the LLD course start? After this, I will launch LLD course. I will, because LLD will require a lot of coding. I will myself need time to code everything out in advance and prepare for the course. So probably like 20 days after the HLD course ends, 20 days or 1 month after. Okay. Yes, because I will see if it say 4 5 weeks of classes, I would have to like prepare well in advance. I would have to write the code. I would have to make sure that I would have to structure the entire course, so it takes time, right? What language will it be in? I have not decided yet. I am trying that I can have both C++ and Java at the same time, and see what happens. Yes, Nimisha, you should be able to unmute yourself now. Okay, let me try.
Yeah, hi Kirti, hi everyone else. So my question is,
Talk
uh,
on chat and I will enable unmuting because I feel there are a lot of people right now. There might
mm,
be a bit of confusion. Okay, so I can see a bunch of questions being asked by Rajat. What does Mongo have by default consistency? We are creating replicas. So Rajat, when we discuss databases next week, so week 3 is all about DB. We'll discuss every database in detail, not every, but the common ones like Cassandra, MongoDB. What are the, now that you understand the properties properly, we will discuss that, okay, which are highly available, which are highly consistent, strongly consistent. And that is how you take the discussions also in system design rounds. So you will be able to decide, you will be able to make decisions on the basis of, okay, what was the requirement? You will be able to choose your tech accordingly. So we will, when we learn databases next week, we will discuss every, like whatever databases we cover, we will cover these points in detail. Okay. Um, cool. I know we haven't talked about load balancer in class. We are actually doing this day after tomorrow. Yes. But I am preparing for interview and I have one question. What layer does load balancer operate? Is it the network layer? How does it identify which service to send the data packet to? See, load balancing happens like at different layers. It is possible. So you could have it at the application level also, right? Like you would send the request to which server, or you could have it in different ways. There are different load balancing techniques also, and different places where you can balance the load. You could be balancing it before databases, before the servers. It is not at the network layer usually. uh, I will discuss it more in detail day after tomorrow, so I hope if your interview is after that, you will be able to understand. Okay. Okay, I am going through more thing. How is Amazon cart stateful? Because it gives personalized ads. That's why. Yes, that was the reason that I was thinking. Uh, Also, you should be able to like your next request, like payment, can be dependent on like the info that is stored, that which is like add to cart beforehand. So your request can be dependent on the previous request. So that is another way to see about, to think about it. So basically, if you are storing the cart info on server or basically in the component, then you can call it stateful. Okay. Strong consistency doesn't make sense for read operations. What do you mean by that? You're meaning that there is no write and only read happening? Is that what you mean? I'll check out your comment again. Partition tolerance is unavoidable. Yes, in distributed systems, yes. Be it mono or micro. Yes, but in mono, that what happens is because everything is on the same server, scaling and everything is very easy, and the partition doesn't even come into picture, right? Over there. Yep. In real-time feature like WhatsApp active status, how can you achieve availability without having consistency? Because if you show, because if you show have only availability, then you will be showing wrong status to other users. Yes, so basically when you're saying active, you're saying active or inactive. So suppose I came active at say 10 p.m. and you can see active at only 10 p.m. It is fine. It is fine. Like, availability is more important. It is okay if you see me being available after 2 minutes, but you should be able to see the status. That is what is more important, correct? So I hope it makes sense. Um, what does the actual design document look like in companies, say a broad-based company? Because in my interview, the interviewer was not satisfied with just theoretical terms. Yes, Nimisha. So that is why we will be discussing functional requirements, non-functional requirements, and in design, like so, whatever terms we discussed today, we are supposed to be discussing all of this, like CAP theorem and like databases that we are going to use. So system design itself is like huge topic, right? So whatever we cover, it is supposed to be there in the document. By the end of the course, you should have the answer. Okay. Can we focus on the topics and not on the interview prep? If we know the topic, the interview cannot go wrong. You are right to it, but what happens is because there are so many topics, people might get overwhelmed. And I don't think I'm focusing too much on interview. What I'm doing is I am trying to tell you that okay, this is important for interview, this is not important for interview, and I'm also giving you tips because there are good percentage of people who are here for interviews and not just randomly. I am covering all the topics as much as possible, but it is good to have interview tips because that will really help you, crack interviews. So, yep. Hey, Kirti, for doubt solving, can we stop the recording if possible? So, I see right now I'm not getting the time in between the course, but once the classes are over, I'm going to edit out all the recordings, and in the content section, you will be able to see the edited videos also. So basically there we will have only like the tutorials and not the doubt resolving and the discussions that we have. So but some people might want like doubt solving also to be recorded and uploaded. Some people prefer the recording to be uploaded as it is, so I'm going to have that as well, and we're going to have both the versions of it. So I hope that will be helpful. Yep. Going through more questions. There are a lot of notes available on the Discord channel, correct? When are we getting the PDF type notes? Yeah, so that is why I'm not understanding why is there so much hype about PDF type notes. I mean, uh, there are a lot of notes available, and I saw that there are good notes also available. But then I will try to type it out and structure it properly and upload it. Right now, what is happening is I'm also preparing for the next few courses. I'm also replying like next few classes. I'm also replying to all the mails. Like I get a lot of doubts over mails and on the Discord. So there are a lot of things that I have to take care of right now. But uh, I will make sure the notes are available. Okay. If we cache in browser stateless system, will it become stateful? So if you are making the decision based on whatever you have stored, yes, it does become stateful. So if your decision is not completely dependent on the data that was coming, and if you're using any data that was there, maybe you could be storing in memory or on hard disk or however you want to store, it becomes a stateful. Um, a sync replication, you are saying will not be consistent and it will have AP. Sync replication will have CP. In very easy terms, yes, you could say that. Yep. Akanksha is asking, do we determine nines per SLA and abide by it? For example, if I say 4 nines, then do I design such a system? Yes. So basically, SLA, it is a service, it is an agreement, right? So in agreement, what happens? So basically, both the parties sign. So if I am using a cloud service provider, they are committing to me that they are going to give me this nines availability. And if they don't do that, I could actually sue them because they're not abiding by the agreement. So yes, we have to abide by that. Rahul is saying, please tell, can microservice be applied on front end? Um, how will you apply microservice on front end? They are on different servers, right? How will you do that, Rahul? What is the difference between mission critical and real time system? Mission critical meaning that if the data is not consistent, you're going to really have some issues. Real time means you are getting the response real time. Like if I'm sending the request right now and if I want the message back right now, it is real time communication. Mission critical meaning that if this doesn't work out or if this data is not updated, something very wrong can happen, like healthcare systems or airline system. Imagine a flight is coming and your update fails, that okay, and then another flight comes at the same time, then the crash can happen, right? So it is a mission critical system, you could say like that. SLA is not asked in system design interview. It is something good to know. When we have two DB instances and one goes down, why do we say that systems availability has gone for a toss? The other DB instance is available, right? So it depends. Maybe right was taken care by one, like some rights were taken care by one DB, some rights were taken care by other DB. Plus now your system is not highly available. The number of lines of your system has now gone down because uh, if this one also crashes, you don't have a backup. You can view it like this. Plus, like if some rights were taken care by that database only, then obviously the problem is going to happen, right? Uh, okay, I'm going through more questions, a lot of questions. Vibhuti is asking, just wanted to ask, why can't we have system which is available and consistent, but not partition tolerant? P stands for partition tolerance and not just partition. Can you please explain why with some example? I'm still unable to understand. See, Vibhuti, partition tolerance means how much you are able to tolerate the partition. You can see the diagram right now also, right? That is there on the screen. So basically what I'm saying is that you cannot avoid partitions. So you cannot make your systems partition tolerant. You can either make the see, you can either make your system, you can either make a system consistent, available, or partition tolerant. You can have only two of these three properties. So you can either have it consistent or available. You cannot make it partition tolerant. Why can't you make it? Because network failures are out of your control, right? You cannot control them. Understand that? Let me just stop sharing also, by the way. Yep, cool. Uh, I hope you understood now, Vibhuti. Were you able to understand? Got it. Thanks. Okay, cool. In case of CDN caching, wherein we are just caching some images, CDN we are going to discuss in detail day after tomorrow, Tanmay. Just wait till then. Day after tomorrow, we are going to discuss PubSub, Kafka, RabbitMQ. Day after tomorrow, we are going to discuss load balancing, caching, CDN in detail. Okay. Um, How server will know which client to respond back in case of stateless? Okay, guys, I feel there's some serious confusion happening over here. Stateless meaning it is not using any data of previous request. But in this request, like because there's a connection, there's a request came, the response will happen, right? I hope, Avinash, did you attend the first three classes? Because see, in order to send the response, you will first send the request and the response will happen over the same connection. Yep. So I hope you understand that part. If you have not watched the first three classes, please do that. Okay. Please share the screen. Want to click picture for LinkedIn. Okay. Give me 1 second. I will try to do that. Cool. Give me 1 second. Okay. Are you able to see? I think not. Give me one more second. I hope you are able to understand the system properly now, though. Yes. Um, okay. I am going through more things. Vibhuti, you can avoid partition tolerant, but those systems cannot be distributed in that case, monolith or single systems. Yes, we can have AC systems, but in case of distributed systems, we cannot avoid. So if you see the definition of CAP theorem itself, it states that you can either have, it is for distributed systems, correct? So you have to think that distributed systems is the key point over there. Okay. Really enjoying HLD for real. I'm really happy to see these comments. You have no idea how much. Um, okay. In the hackathon topic, two clients means two different users with different logins. Yes, two usernames. So it will be same, like the code will be same, but usernames and users are going to be different. Yes. Uh, Share screen when you explain things. I was sharing things. Okay. How do we decide when we need stateful and when to use stateless systems? So when we do API design and when we discuss details like that, you will be able to understand. Today, I just introduced the terms to you, like we will discuss API design and details, then you should be able to follow. Cool. Okay, do we support groups in the hackathon? Completely up to you. You can decide the requirements and decide accordingly. There is no hard and fast rule for front end, for back end, nothing like that. Try to like so you are supposed to decide the functional requirements. Try to do as much as possible. Okay. Is CDN used for caching? Yes, day after tomorrow we are going to cover caching and CDN. Cool. I hope you had a good class. And okay, I don't want to delay the class so much so that your entire energy is gone and you don't show up the next 2 days because we have 2 more days to go for the week. Okay, quickly reading Tanmay's question. The question is for stateless and stateful systems based on an answer you just gave. Can you once read and get back? If it's not related to, it's okay to leave the question. Thanks in advance and sorry for the copy. Okay, I am not sure. Can you please paste the question again on the Discord? I will go through it again. I don't understand which question you're talking about. Just paste the question on Discord. I will look into it in detail. Okay, if there's any confusion, I hope I'll be able to clear it out. Okay, I hope you had a very good day. I want you to show up next 2 days also. Now we have switched to Teams. Everything is going good. Yes. Thank you so much for showing up. And I'm really sorry again for these starting 10-15 minutes. And yep. Good night, everyone. Have a good night. Seem like you're on steroids today. Is that a compliment? Because I'm too excited? Not sure. Cool. All right. Bye, everyone. Good night. Bye.